actually because relational model does not allow such a multi-value. So same reason, nested relation. It's a very simple concept in terms of object-oriented. You can define object like a person. Person can be used for employee. Person can be used for, you can instantiate, right? Relational model, no. That's the main difference between relational model and other programming languages, especially for object-oriented languages. Because of that, we discuss a lot and practice a lot database programming. Because of that, we have the impedance mismatch. Their data structure, their basic, their fundamental are totally different. This is the example. Okay? So we cannot address such a thing. Somebody still asks after the couple of class, like, why do we need to this one? In the programming class, no, we can easily create the data type or object for nested or such a multi-value. It doesn't matter. We can create the vector. We can create the list. Relational model, no, doesn't. Because only one value for each column. That's a huge drawback of the relational model. However, because of that, we can search data very quickly. And also, we can manage very large database without that's a limitation, but because of that limitation, we can, it's not flexible, but that is one of the reasons here. Relational model is one of the top database systems. So that's the example. What about this one? Do you think that this, I did such a design. We'd like to check whether this is the first normalization form or not. Do you think this is the first normalization form or not?
Yeah.
Yes?
No.
No?
Yes.
Why not?
Yes.
Check each attribute. What? Composite? No composite. No multivariate. No nested. This one okay. This one okay. This one okay, but this is the multi-value. So this is not the first normal form. What about this one?
No.
It has multi-valued one. It's the same thing. And what about this one? This is okay. Okay. Even though this does not make sense in real case, this is okay. So answer is that this is not, this is the okay. But still problem, we will see how can I address that. Then how can we make this non-first normal form? How can we make then the first normal form? I ask you, you need to keep your mind. Segmentation. We can segment the location. This is one of the solutions, but not a good solution. Still have the redundancy. So the better way is we can segment, take apart. That's the reason why don't you go back to the very beginning of this semester. You have seen the company database, right? Company database has the table for department location. Somebody may be curious, why this is the table? This can be part of the department. Yes, that's true. But according to the definition of the relational model, no. Because of that, many students complain when I design in your first project, when I design the database that I select, for example, university database, company database, a hospital database, whatever the database, I have only the 10 entities. But later, when I create the database, most of the time, your number of tables will be increased because of that. Also, when you are joining the real project, like the big project, mega size project, you have the 2,000, 3,000 tables. Do you know why? Because even one entity will be 100 tables because of that reason. Each table is very small, never change it. It's called sometimes the code table. Here. One parameter, like a small table, it has 1, 2, 2, 1, 2, 3. So one means it's the freshman. Second is the sophomore. third is the junior, and that's one table. Okay, or major. So that's the reason even though we have the 2,000 table in our database, only few of them are important, major table. Okay, okay. So that is so what about this one? This is the nested relation, so it cannot be the first normal form. We need to decompose segment. So this is the first normalization form. So first normalization form, you need to take a look at only the attribute. Okay. The second normal form. Then after you make the first normal form, second normal form is we are going to take a look at the functional dependency. In the functional dependency, it has only full dependency. What does that mean? Full dependency. Full dependency means here in this example. So social security number, comma P number determines hours. All attributes should be determined by social security number plus P number. Okay? Like this, but here, social security number, P number, e-name is a full dependency? No. The e-name is determined by social security number only. This is called partial dependency. So, in second normal form does not allow such a partial dependency. In other words, all prime attributes should be used to determine the non-prime attribute. Let's see the example here. What about the hours? Hours is determined by P number and social security number. It's a full dependency. However, e-name is determined by social security number. This is a partial dependency. And P name plus P location is determined by P number. This is a partial dependency. So this is not a second normal form. Solution? How can you make them the social, the second normal form? Segmentation. How can we segment? Segment functional dependency by the functional dependency. So this is one table, this is one table, this is one table. Then what about this one? It's a full, it's also full, it's also full dependency. So this is the second normalization form. This is one tip. What if you have the prime, single prime attribute? Only one prime attribute, which means it's automatically second normal form. Why? Because you cannot make the partial for the single. So you don't have to worry about too much. So that is the second normal form. So next one, do you remember the transitive? Transitive is the x determine y, y determine z. So x determine z. No transitive. That is the third normal form. That's easy. Let's see the example of this one. Somebody may be curious. Social security number can determine this one. Why? Because it determines D number determines this one. Yes, because of transitive. However, if you allow transitive, how many different meaning? Two different meaning. So to avoid that, third normal form does not allow such a transitive. Then how can make it the third normal form? Segmentation. By what? Functional dependence. Then you can see the third normal form. This is the first, second, third normal form. First normal form, you can check the attribute by attribute. Okay? Atomic value. No composite, no multi-value, no nested. Second normal form, full functional dependency. All non-prime attributes should be determined by all prime attributes. Third normal form, no transitive. Okay, that is up to the first, second, third. Good news, as I said, even though you do not learn this one, when you design the database intuitively, it's up to third normalization. Nobody wants to mix the employee and department, right? That's the third normal form. So nobody wants to mix the student and instructor. That's the third normal form. So that is the third normal form. Most of the case, 95% it can be addressed by the third normal form, which means 95% you can easily design. But the problem is usually the other less than 5% that cause the problem at the time you need to apply. So such a thing. There is one more thing, then I will stop the earlier today a little bit, okay, because I have the candidate meeting. So this is the one page. Today's lecture can be summarized as the one page. The all attribute depend on the key, right? And second normal form is whole key dependency, and nothing but the key. If you determine the, it's nothing but the key, but this is not the key, right? So this one is nothing but the key, okay? Then another one is the BCNF. BCNF. BCNF is a Morse code. Have you ever seen this name code? It's the Dr. E.F. code who proposed the relational model. And Morse is his colleague. So Morse and the Dr. E.F. code found, even though this is the transitive, okay? But that's a little bit different. Let's take a look at this example. What about this? Property ID, country name, and lot number area. So we can find the property ID determine country name, lot number, area. This one, country name, lot determine the area and property ID. And area determine this. Country name plus lot number is another candidate key here. Okay, so this is a prime, prime, prime. So what about the first normal form? Yes, it's a first normal form. What about the second normal form? It's a fully determined by primary key. And what about this one? It's a determined by non-prime. So it's not partial. It's a determined by the non-prime. Okay? So it's a determined by non-prime attribute, so it's okay. The third normal form, is it transitive or non-transitive? No. This one determine this one, then go back. This is not considered as the transitive. Why? It looks like the transitive, but it's not. Because prime attribute determine this, then go back. It's a determine each other. So it's not transitive. It doesn't create any other dependency. So you love me and you love my you love your parents, your mother loves you. So it's not. There is no third, right? Right? So that's not considered transitive, so it's a third normal form. However, in real case, this causes the problem. This causes some redundant information. So if you consider this is the transitive, it's called the pseudo-transitive. If you consider this one, that's the BCNF. So BCNF, you do not allow this one. How can you find this pseudo-transitive? If this determine non-prime attribute determine prime attribute. So what can be the solution? Segment. We can take out this one later. So let's quickly look at the example of that. So here, so this is the third normal form. Okay, area determine price. Third normal form. Then we can take out the area determine country name. Okay, area determine country name. Actually, we don't have to, but may cause the little bit redundant information. Okay, that's a little bit harder than the previous one, but we consider. So most of the system up to the BCNF. There are more, 4th NF, 5th NF, something NF, okay? But they are very special case. So you can understand in case you encounter, it's not the problem of the BCNF, it's not problem of the 3rd NF, but you may encounter something duplicate data. Or your system is slow, unexpected data. Then you can check the 4th normal form, 5th normal form, from the textbook or internet or something other reference. Then you can figure it out. Most of case solution, decomposition by finding the such a functional dependence. That is a BCNF. So that's done. So you can do the quiz. Okay. So I'm not sure when is the due date. The GA will adjust if not covered properly. Okay, that's it. So today, Neymar, please take care until I'm back. Okay, I will be back around 3 o'clock. No, we don't have to quiz. Okay, so today I'm going to quit a little bit earlier. If you have any questions, the GA can take care. Thank you.
I have a question.